Okay, you're live.
Hi, I'm Austin,
I'm Otacon.
and today we're going to be presenting about the geology of San Francisco. Before we start talking about San Francisco, we're going to talk about the different types of plate boundaries. There's three different types of plate boundaries. You have convergent, you have divergent, and you have transform. So the convergent plate boundary is when two tectonic plates collide head-on, forcing one to subduct under the other. The subducted plate, rocks will start to fall off or be eroded and turn into magma, which will eventually combine with the overriding plate, as you can see in the model here. And then this will be cause for volcanic activity such as the Sierra Nevadas in California. The second plate boundary is the divergent plate boundary. Now this is where two tectonic plates will separate, allowing magma to rise to the ocean floor, and this will form the mid-oceanic ridges, which are basically underwater mountain ranges that can sometimes be up to 2 kilometers high. And then third, we have the transform plate boundary. This is where two tectonic plates will slide past one another, and it is the boundary that San Francisco currently lies on, and aka the San Andreas Fault Line.
Which you can learn more about at Zach's presentation if you choose to go there after this.
Okay, so around 200 million years ago, all the continents used to be one, and it was called Pangaea. 175 million years ago, a convergent plate boundary forced Pangaea to separate, and it created the Atlantic Ocean and the Mid-Atlantic Ridge. There also used to be an ancient plate called the Farallon Plate, and it was subducting under North America. And the remnants of this plate are the Juan de Fuca Plate, which you can find in British Columbia, and the Cocos Plate down in Mexico. The subducting of the Farallon Plate caused for terrains to be formed in San Francisco. Terrains are basically groups of rock that share a common origin or creation, I guess. And Alejandro, do you want to take it away?
Yeah, so the Farallon Plate, one of the reasons it was subducting was because there was a divergent plate boundary right here by the Mid-Atlantic Ridge, and there was a divergent plate boundary between the Pacific Plate and the Farallon Plate, and this forced North America and California to collide, and like Austin said, created terrains. And I'm going to talk about which rocks make up these terrains. Now, there's 5 different terrains in California, which consists of three different families of rock. The first one I'll talk about is the one from Marshall Beach to Point Reyes, and this consists of basalt, greenstone, and serpentinite. Basalt is an igneous rocks being rocks that are formed when magma cools, which is formed in the divergent plate boundaries. Now, it's formed when the magma from the asthenosphere touches the oceanic water and it cools really quickly, and that's what gives basalt its unique pillow-like shape. Now, over time, as basalt sits, it goes through a metamorphic transformation and can transform into the metamorphic rock greenstone. Now, metamorphic rocks are a type of rock that changes its form after being exposed to heat and or pressure. For basalt, what happened is over time it developed chlorite, which makes it turn into greenstone, and chlorite is what gives greenstone its unique green look. Now, over time, as where greenstones sit, it can turn into serpentinite, which is even greener than greenstone, and it also has a very soapy texture, and serpentinite is also a metamorphic rock. Another terrain that can be found is the Mount Sutro Twin Peaks terrain, which consists of a lot of chert. Chert is a sedimentary rock, sedimentary rocks being rocks that are compressed of smaller rocks. And the way that chert is formed is it's formed near mid-oceanic ridges from radiolarian, which is a single-celled aquatic animal that after it dies, its skeleton falls to the ocean floor and combines with clay to form a sort of ooze. Now, because earthquakes are very common at mid-oceanic ridges, when an earthquake happens, this lifts the ooze off the ocean floor, and because the skeletons of the radiolarian is heavier, it falls first to the oceanic floor, and then the clay falls, and this forms layers. And as this process repeats itself over and over and over again, you get chert. Now, another terrain in San Francisco is the Nocto Russian Hill Plate Tower terrain, and this consists of sandstone. Now, the sandstone found in the Bay Area was formed when the volcanoes like the Sierra Nevadas created granite, another igneous rock that is formed when magma cools in volcanic tubes over millions of years. And this granite eroded and fell into the trench of the subducting Farallon plate. And as the Farallon plate subducted, this compressed the eroded granite together to form sandstone, which sandstone is also a sedimentary rock. And there's two other terrains here, one of them that consists of kind of basalt greenstone serpentinite family, and one of them that consists of more or less sandstone. And that is the geology of San Francisco. Thank you.
Thanks.